The next logical operation we're going to learn about is called the conditional, and it has the form of if something, then something. Given statements P and Q, the new statement, if P then Q, which is denoted like this, is false when P is true while Q is false. Otherwise, it is true. In other words, the only case where this new statement is false is a case where P is true while Q is false. Otherwise, the statement is true. Here's another way of thinking about it. If P then Q, yes, the statement if P then Q is a promise that whenever P is true, Q is also true. Now the promise is broken. So think about how could this promise be broken? So the promise is broken. In other words, if P then Q is a false statement, only in a case where P is true and yet Q is false. That's the only way for the promise to be broken. The promise says if P, then Q has to happen. If P happens, then Q has to happen. The only way to break that promise is where P is true and yet Q is false. And as long as the promise isn't broken, we consider this statement to be true. For example, let E of x be x is even and I of x be I is an integer. So let's say I say this, if E of 10, then I of 14. So this is true. This is a true statement. This is a true statement. So now this new statement here, what is it saying? It's saying I'm promising you that if this is true, then this has to be true. Well, this is true and this is true, so this is a true statement. How about this? If 10 is even, then 1.4 is an integer. That is making a promise that if 10 is even, then 1.4 must be an integer. Well, the problem is 10 is indeed even, and yet 1.4 is not an integer. So this is a false promise, so it's therefore a false statement. This here we're saying if 9 is even, then 14 is an integer. Well, the condition of this promise, the precondition was never fulfilled, right? This is saying I'm promising you that if 9 is even, then 14 is an integer. Well, I don't really care what 14 is. I don't care whether it's an integer or not. The point is we never fulfilled the first stage of the promise. So we have no obligation for 14 to be an integer or not, but this is a true statement. Now, how about this? How about if I say the following, if 9 is even, then 1.4 is an integer. Okay, now both of these are false, right? 9 is not even, 1.4 is not an integer. However, well, let's think about it. So I'm saying there's a promise here. If this is true, then this is true. Now, this is not true, so therefore this is not required to be true. It could be true, it could not be true, but it doesn't really matter. So this entire thing is a true statement because the promise wasn't broken. Again, the promise was that if 9 is even, then something. Well, 9 is not even, so there's no way to break the promise. Here's a truth table for if P then Q. So we have as usual, we do true, false for this column, and then true, true, false, false for this column. So if in the case where P is true and Q is true, then if P then Q is true. If P is true, in the case where P is true and Q is false, then the result is false. That's the only case where it is false, because that's where the promise is broken. Again, the promise says if P is true, then Q has got to be true. But here we see a case where P is true and yet Q is not true. So therefore the promise is broken and the statement is false. But in all other cases, the promise is not broken. For example, here I'm saying if P is true, then Q must be true. But P is not true. So there's no obligation for Q to be true. It happens to be true. It doesn't really matter. The point is Q is false. So therefore I have no obligation to have Q. So therefore this promise is never broken. How about this? Here I say if P then Q, but P is not true. So all I said was if P is true, then Q has to be true, but P is not true. So therefore Q does not have to be true. So therefore the promise was not broken and the result is true. Here's an example. Suppose a politician promises, if I'm elected, wages will go up. Okay. we could have put the word then in over here, but in English, we often omit the word then. We just say if something, and then the consequence of that, right? We sometimes omit the word then. We could put it in. We could say, if I'm elected, then wages will go up. Okay, now, so let's make a table like this. We have a few possibilities for whether the politician is either elected or not elected, and wages will either go up or not go up. And we would like to know, is the promise true or not? So let's say the politician is elected and wages go up. Well, then the promise was true, right? The politician said, if I'm elected, wages will go up. Guess what? They were elected and hey, wages went up. So the promise was true. Great. How about if the politician is elected, that happens, and wages do not go up? Well, then the politician, well, I don't know if you say they lied, but they broke their promise, right? Wages did not go up. So therefore, so then the statement that the politician made was a false statement. Okay, PolitiFact, ask PolitiFact, they'll say it is false. Now, how about this? How about the politician is elected and wages? Sorry, how about the politician is not elected? Right. So in other words, it is false that the politician is elected. The politician never gets elected, and yet wages still go up. So you might say, well, the promise was not true because politicians said, if I'm elected, then wages will go up, and they weren't elected and wages went up. However, that's not really what the politician said, right? The politician never claimed that if I am not elected, wages won't go up. Politician did not say that. Again, you have to, you might say, oh, it's just political speak and it's lawyerly talking, but what did they say? What did the politicians say? They said, if I'm elected, then, wages will go up. Well, they never said what would happen if they weren't elected. So if the politician was never elected, so what if wages went up? The promise was still true. If I'm elected, wages will go up. This was not broken. The promise was not broken. So it's true. Now suppose a politician is not elected and wages don't go up. Well, still the promise was not broken. The promise was, if I'm elected, then something will happen. But the politician was not elected. So therefore, there's no requirement that wages should go up. So the promise is still considered a true promise. Now in English, which is much more difficult than math, okay, English is much more difficult than math. In English, the statement if P then Q can be expressed as the following. By the way, when I say English is more difficult than math, I mean it. And if you mastered English, which you all did, then you should be able to master math because it's actually easier than English. Okay, if P then Q can be expressed in many different ways in English. Okay, so here's going to be like a list of 10 different ways. So the obvious way is if P then Q. Okay. Another way to say it is Q if P. Right? So, if I pass this class, then I can take the next class. Right? So another way to say that is I can take the next class if I pass this class. Okay, so that's another way. Here's another way to say it. Q whenever P. So what does that mean? That means whenever P happens, Q must also happen. That's what if P then Q means. Remember, what does if P then Q mean? It's a promise that whenever P happens, then Q happens. So what this is saying is whenever P happens, Q must happen. By the way, I didn't write this out, but another way to think about if P then Q is think about it as that P forces Q to be true. Okay, P forces Q to be true. So whenever P happens, Q happens. So that's P forcing Q to be true. Here's another way. Provided P, meaning provided that P, Q, meaning provided that P happens, then Q happens. Here's another way. Q provided that P, meaning P is enough to cause Q to happen. Here's another way. Whenever P, then also Q. Here's another way to say if P then Q. P is a sufficient condition for Q. So what does that mean? That means that P is enough to make Q happen. That means whenever P happens, Q must happen because P is enough to make Q happen. It's a sufficient condition for Q. Here's another way. For Q, it is sufficient that P. Okay, so that's just the same thing as the previous one. Here's another way. Q is a necessary condition for P. So what does that mean? That means whenever P happens, it is necessarily true that Q, meaning Q is a necessary condition for P, meaning, again, whenever P happens, Q must necessarily happen. Here's another way. For P, it is necessary that Q, meaning same thing. If P happens, then it is necessary that Q happens. Here's another way. This is a little surprising. P only if Q. Again, this is not a typo. It's not a typo. We're expressing the idea of if P, then Q. One way to express that is by saying P only if Q. So for example, you might say, if going back to the earlier example, if I pass this class, then I can take the next class. Okay. Another way to say that is I can take the next class only if I pass this class. No, I'm sorry, that's not true. I'm sorry, that's not true. That's not true. I'm sorry. Let's go back. Sorry, no. Another way to say that is, actually, let's forget that example. Let's look at the next page, the next slide, where I have a better example. Okay, so this is from the U.S. Constitution, Article 1, Section 3. No person shall be a senator who shall not have attained to the age of 30 years. Okay, in plain English, what this is saying is you cannot be a United States senator if you aren't at least 30 years old. Okay, so here's a few different ways to say it, and these are all true statements. If someone is a U.S. senator, then they are at least 30 years old, right? Again, the fact that someone is a U.S. senator, that must mean that they are at least 30 years old, because otherwise they wouldn't be able to be a U.S. senator. A person is a U.S. senator only if they are at least 30 years old. So notice here that this is an example of using only if, right? So if someone's a U.S. senator, then they are at least 30 years old. A person is a U.S. senator only if they are at least 30 years old. Being at least 30 years old is a necessary condition for being a U.S. senator. Meaning you need to be at least 30 years old. It's necessary to be at least 30 years old in order to be a U.S. senator. Here's another way. That knowing that someone is a U.S. senator is a sufficient condition for knowing that they are at least 30 years old. But, it doesn't work the other way. You might, it would not be correct to say that being it would not be correct to say that knowing that someone is at least 30 years old is a sufficient condition for being a U.S. senator, for knowing that they are a U.S. senator, because, there are lots of people that are 30 years old and they're not U.S. senators, right? So, okay, great. End of this.